welcome back to my video. Today I'm going to be testing quantum data for randomness using an AI model. So today I'm going to use Rigetti's QVM or quantum virtual machine to generate random numbers and then check them through AI. So AI is going to predict the next number. Huge shout out to Lightwriter for sponsoring this video and also giving me access to Rigetti's systems. So let's get started. First, I'm just going to install some dependencies, so I'll just speed this up. Okay, so here, as you can see, I generated sequences. So I'm going to generate three sequences. One from the 9q square QVM, which is an ideal system. So it's an ideal QVM, quantum virtual machine. So you can see how many ones it has. It generated 1000 flips. And then I have a noisy system, which is the 9q square noisy QVM. So it's a noisy virtual quantum machine. This, as you can see, it has a little bit more zeros than ones. And then we have the bias system. Bias system, I artificially added more zeros than ones. So you can see there's definitely more zeros than one. Now, let's do some statistical analysis first. So if I do that, you can see here that you can see that it has pretty good randomness, other than the bias system doesn't have good randomness results. Let's take a look at the sequences to see how they look like. This is the ideal system. Ideal system, you can see that almost the same amount of zeros as ones, but in the noisy system there's a little bit more zeros than ones, and the bias system we put a lot more zeros than ones. Now let's train AI model on it, and I have three models. You can see logic regression, random forest, and gradient boosting. So I'm going to train now. Okay, so as you can see here, this is the results. You can see for logic regression, it could not predict ideal as well. It could predict noisy, but it could predict bias the most. Random forest, it could predict ideal a little bit better. Noisy, it couldn't predict as much, but you can see the biased, it could detect a lot more. And gradient boosting, it couldn't detect all of them. Now, let's check out some extra graphs just to see how it would run with multiple runs. Okay, so here we have our results. You can see ideal, it could predict like almost 50% of the time. So up to 50% of the time, ideal can predict. Noisy, it could predict basically 50% of the time. While bias systems, you can see it's able to predict a lot more than usual. This shows that quantum data is entropic. So it has entropy inside. Next time, I'm going to run on a real quantum computer, Cepheus, which is also made by Rigetti. So stay tuned for that. Okay, bye guys. Hope you learned something.